Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hi, I'm Dr. Rohana. In this video, I'm going to explain to you how to analyze clamper. Now, let's look the example. Let's say we have this circuit and we also given the input waveform. So this is for the positive cycle and this is for the negative cycle. Tips in order to know the direction of our waveform, either it's going upwards or downwards, is by looking at the arrow of the diode here. So the arrow of this diode, if you look here, it's going down. So meaning that our waveform will be moved to the downwards. Next, the first step is we need to identify the direction of the forward at the positive cycle or at the negative cycle. From this circuit, we can identify the condition for the forward or reverse. So first, let's check the current flow. So the current flow is from positive to the negative, and the direction of our diode is here. So it's similar or matching with the current direction. So meaning it will be forward during the positive cycle. So next, for the negative cycle, we need to change the polarity of our input here. So here it will become as a positive and here will be as a negative. So the current direction is from positive to negative. And if you look here, that the direction of our current and of our diode is not matched. So during the negative cycle, our circuit will act as a reverse. Now let's look more detail for the forward analysis. So here we already changed the diode during the forward as a short circuit. So now let's follow the step by step of the analysis. Okay, the first step we already done, which is we already identify the forward direction. So next, for the second step, we need to analyze the forward circuit. So it means that we need to identify the loop for our KVL. So here, for calculate the VC at the third step, we need to find out the loop. So here is the loop where we call it as a inner loop. Now we're going to identify the VC. Okay, so now this VC is equal to what? By using the KVL of the clockwise, we're going to have negative V. Okay, now here is the VC voltage for the capacitor. So we need to set the polarity of this VC. So the polarity of this VC is follow the direction of the current polarity. So what is mean the direction of the current is from positive to negative. So means that positive is here and negative is here. It's follow the direction of our current here, like this one. Okay, so now we have set the polarity, and back to our KVL. By using the clockwise, we have the negative voltage. Now polarity is positive, so plus VC is equal to 0. So from here we can get that VC is equal to V. After we find out this VC, next we must calculate the V out. So V out must be analyzed from the outer loop. So because we want the V out at here, so we analyze it from the outer loop, which is the outer loop is here. So the current from positive to the negative, we call it as a outer loop. By using KVL of the clockwise, okay, we get that negative V plus VC plus V out is equal to 0. Since we know from here that VC is equal to V, so we can replace the value of the VC. So here we get negative V plus VC is equal to V plus V out is equal to 0. And here we get V out is equal to V minus V, and V out is equal to 0. Alright, after we calculate the V out, next we're going to plot the graph. Okay, now let's plot the graph. So we know that our V out is equal to 0 volt for the positive cycle. So now from the input graph given here, this is our positive cycle. So we're going down to the output graph for this positive cycle. So at this moment, we can see here that our V out is equal to 0. Okay, now let's analyze for the reverse condition. So during the reverse condition, we know that our diode here looks like open circuit. So we can move up or remove our diode here. So it will become as an open circuit. So for the analysis, we need to identify the reverse direction. So again, for the reverse direction, we know that our current flow from the negative cycle. So from the negative cycle, the current will flow like this one. Okay, from positive to negative. Since it is the negative cycle, so we need to change the polarity of our input here. Positive, negative. Okay, now let's analyze our V out. Okay, since we know that our VC here is equal to VC forward, which is the VC forward is equal to V. We already calculate at the forward condition, and now let's look for the V out. So here this V out is from positive to negative at the outer loop. By using the KVL anti-clockwise, so here we have negative V out. Again, polarity of our capacitor here, never change it. So negative VC, negative V equal to 0. Let's do the calculation. We replace the value. We know that VC forward or VC is equal to V. So we can replace this VC to V. So negative V out minus V equal to 0. And next, we can get negative 2V is equal to the V out. So meaning that our V out is equal to negative 2 volt, negative 2V. Now let's replot the graph. Okay, for the graph, we know that at the reverse condition, our V out is equal to negative 2V. So, we're going to look at the negative cycle. So, this is a part of the negative cycle. So, we make it down. Okay, so then we have the V out here, 2V, and we plot our graph until 2V here. Okay, so finally our graph is like this, 0. Okay, so that's our final answer for the graph. So now how are we going to check either our answer is correct or not? Again, remember we need to measure the total swing of the input and the output. Since here the total swing for the input is 2 volt, 2V, and our also here is 2V, so it's same or equal, so meaning that our graph here is correct. And again, remember that what the tips I give you, that this waveform will be moved or shift to the down. So our answer is show that our waveform shift to the down direction. So again, it's proof that our answer is correct. Okay, that's all. Bye.